Welcome to the SAT Mathematics video. In this video, we're going to look at quadratic, cubic, and exponential equations. So we're going to look at linear graphing linear equations in the video of coordinate geometry. So in case you're wondering why that's not there in this video, that's why, because it's another video. And with that, let's begin. The first thing we're going to look at is solving quadratic equations. So the first method we use is factorizing. This works if you can find two whole numbers that have a product which is equal to the coefficient of the first of the x squared term into multiplied by the last term. So if you can find two numbers that have a product of minus 10 into 6, which is minus 60, and if those two same numbers also happen to add to be the coefficient of the second term, which is minus 11, then you can use factorization. So these are all the numbers that have a product of minus 60 or minus 10 into 6. Now minus 1 plus 60 is minus 59, minus 1 plus 60 is 59, this is minus 59, this is 28, minus 28, 17, minus 17, 11, minus 11. So we actually find an answer. We actually find that we have two numbers that have a product of minus 60 and also happen to have the sum of minus 11. Now, since because minus 15 plus 4 is minus 11 and 4 into minus 15 is minus 60. Now, given that we have these two numbers, note that I can also write minus 11 as minus 15 plus 4, and therefore I can also write minus 11x as minus 15x plus 4x. So that's what we're going to do next. We're going to rewrite minus 11x as minus 15x plus 4x. Then we're going to take common factors of the first two terms. 3x is a common thing, and then we get 2x minus 5 in brackets because of simple division. So I'm not gonna, and then we can take 2 out of the second brackets, and that would leave us with 2x minus 5 in the same brackets. If you're doing factorization correctly, what is inside the brackets should be the same for both. So if this says 2x minus 5, this should also say 2x minus 5. If they are not saying the same thing, you're doing something wrong. Then you can take the term in the brackets, you can take 2x minus 5 common. That will produce another bracket that has 3x plus 2 inside. Now what this equation basically tells us is the product of 2x minus 5 and 3x plus 2 is 0. Therefore we know that either 2x minus 5 or 3x plus 2 is 0, and that is how we solve the equation. We say either 2x plus minus 5 or either 3x plus 2 is 0. And that gives us the solutions for x. So x has to either be 2.5 or minus 2 by 3 for this to be true. And that is how you solve the equation using factorization. But once again, as I said earlier, this might not work in some cases. It will only work if you can find two numbers that are the product of the that equal the product of the last term, whose product equals the product of the last term multiplied with the coefficient of the first term, or if you can find, and those two numbers also have to happen to add to be the coefficient of the second term. So they need to equal b. So the product of c and a, where c is the last term and a is the first term, two numbers that equal that, the product of two numbers that equal that also have to add together to equal b, which is not always going to be possible. So what we can do instead is, so let's look at the examples of 5 and 31. 31, you can get positive 31 by multiplying 1 and 31, or minus 1 and minus 31. There is no other way to do it. And these respectively add to minus 32 or 32 and not 5. In this case, we cannot factorize, so we use something that is known as the quadratic formula. So a is nothing but the coefficient of the first term, b is nothing but the coefficient of the second term. Note that it takes the sign, so b is minus 11 and not just 11, and c is the last term, which once again takes the sign, so it is minus 10. It is minus 10 and not just 10. And you need to memorize this, and we can substitute these values into the equation. So those are the values that we got. We are solving the same equation as we did for factorization, just to see that both of them yield the same answer. So we substitute a's everywhere, we substitute the b everywhere, we substitute c everywhere. Minus of minus 11 is 11, minus 11 the whole square is 121, minus 4 into 6 is minus 24, into minus 10 is 240, 2 into 6 is 12. So that's what we had. When we further solve it, 121 plus 240 is root of 3 is 361. So the x, note that the quadratic equation, it gives you the values of x. So we can say that x is equal to either 11 plus or minus root of 361 by 12, which is nothing but 11 plus or minus 19 by 12, which means that x is equal to either 30 by 12 or minus 8 by 12, which is equal to 2 by 5 or minus 2 by 3, which is the same answers as we got the last time. These solutions that we get of x, these values of x, are called the roots of the equation, and b square minus 4at within the root, which we saw, is known as the discriminant. Now the discriminant is very important because if the discriminant is positive, the roots are always going to be real and distinct, which means the two roots, quadratic equations always have two roots. This means that if the discriminant is positive, the two roots are going to be real numbers, and at the same time they're going to be different. They're not going to be the same value. If the discriminant is 0, they are going to be real numbers, but the two roots are going to be equal to each other. And if the discriminant has a negative value, so if b square minus 4ac is negative, the roots are going to be imaginary numbers, right? Distinct imaginary numbers. Now, another thing that comes up is graphing of quadratic equations. If the value of a is positive, it is always a smiley face. If the value of a is negative, it is always a sad face. If it intersects with the x-axis, the points at which they intersect are the roots. If the root is equal, there is only one. If the root is equal, there is only one intersection. Where the case where the discriminant is 0 and there is only, the roots are not unique, so both the roots are the same. This point, which is called the minima, or this point, which is called the maxima, will lie at the x-axis. If the discriminant is negative, as in none of the roots are real, the entire graph will lie either entirely below the x-axis or entirely above the x-axis, based on whether a is negative or positive. So you'll often get equations like this. They might ask you to predict the equation of this graph that is shown. So the first thing we know, this is an upside down parabola, or it is a sad face, which means that the value of a, or the coefficient of x squared, has to be negative. So we can immediately get rid of those that are positive. This leaves us with option B or D. Now in option B, something you will notice is that the discriminant is -8. This means that its roots are imaginary and the graph would lie entirely below the x-axis because a is negative and the discriminant is also negative, which means it does not have any real roots, so it cannot be D. Therefore, we find it's B. We can factorize B to see that it has two real roots that are both positive. In case this did not have a negative discriminant, what you'd have to do is you'd have to find the values of x in both these equations and see which had both values of x being positive, and therefore you'd be able to arrive at the correct option, which was B. Another thing, cubic equations are something that the SAT, I haven't really seen them. It's not something that is extremely important, but I do think it is something that is easy enough to be potentially asked. So here is help you, if they ask you to identify the correct equation, the correct graph for equation for any cubic graph. If a is positive, the y values will be increasing from the left to the right. So as you can see, it is going upwards from the left to the right. If it is negative, it is going downwards from the left to the right. If a is negative, whereas the coefficient of the x cubed term, or the first term. If it has three equal real roots, it will not have such noticeable bend. So it will just have this very discrete sort of bend, and the midpoint of or what we call the point of inflection in calculus would lie at the on the x-axis if it had three equal real roots. If you have three distinct real roots, it will cut the x-axis at three distinct points. And in this case, but just in both of these graphs, I've mentioned that a is positive because it is increasing from the left to the right. If the roots are real, but two of them are equal, we'd have a local maxima or minima touching the x-axis, and we'd have it cut at another separate point. So if it touches the x-axis at only 2 points, where one appears to be a local maxima or minima, as in a local peak or a trough, there are three real roots, out of which two of them are equal. In this graph, we can clearly see that a is negative because it is decreasing from the left to the right. If there is only one real root, and there always will be at least one real root, there will always be either one or three real roots, and or two real roots as well. Apologies about that. Yeah, so in this case you would have one real root and two imaginary roots. So if it only cuts the x-axis at one point, and that one point is not the, and you still have this discrete up and down curve above or below the x-axis, that does not mean it has three roots, all of which are equal. It means it has three roots, out of which only one is real and the other two are imaginary. And over here, just for the sake of understanding, once again I would say A is positive because it is increasing from the left to the right. Now, I haven't really seen them ask questions about cubic equations throughout my practice test, but I think it's handy that you know how these graphs are drawn, so I've put it up regardless. Finally, we're going to look at exponential equations. Once again, I did not really see them ask questions about drawing exponential equations, but if you see a graph of this shape, note that it can be oriented differently. So it can be reflected of the y-axis, so it looks like that. It can be reflected it can be reflected of the x-axis, so it looks like that. It can be reflected of the y-axis, so it looks like that. It can be rotated about 180 degrees, so it looks something like that. But if you see this general shape, it's an exponential graph. With that basic knowledge in mind, the only kind of questions I see them ask for or I can recall them asking for exponential questions or exponential equations or something like this. So the key is you first need to get both of the bases to be the same. Here the base is 32, here the base is 2. We cannot work with that, so we need to convert this to an exponential term where the base is 2. Now 32 is equal to 2 raised to the power 5, so we rewrite 32 as 2 raised to the power 5. Now, if once the base is the same, we can in order for both of them to be equal, the exponents also have to be equal. In other words, this condition on the screen needs to be satisfied. Then we just solve the equation using standard methods, and we get x has to be 0.4 in this, and we have solved the question. A final type of question that I do want to discuss is something like this. So they may ask you either to solve the system of equations or find the coordinates of intersection. Now, if you have a graphical calculator, you can graph both of them and quickly find the point of intersection. Don't need to solve it, but in case you need to actually solve it, this is how you do it. You first need to imply substitution. So we substitute 4x plus 1 over here. We then take everything to one side. So x squared plus 4x minus 4x, so the x terms cancel out, minus 3 minus 1. That's x squared minus 4. Now this is nothing but a squared minus b squared. We can see a squared minus b squared is equal to a plus b into a minus b. So therefore we can arrive at that, following which we solve the equation. If the product of two numbers are 0, one of these numbers will have to be 0. So either x plus 2 or x minus 2 need to be 0. Therefore x is plus or minus 2. Once we have found that, we can just substitute this value of x to find y. So if x is plus 2, y is 9. So that is the first coordinate of intersection. If x is minus 2, y is minus 7. And that is the second point of intersection, or the solution of the system of equations. So it is pretty simple to do. And with that, in the next video, we're going to look at geometry 1, which we're basically looking at basic things like angles, triangles, and similarity. And with that, thank you guys. Have a great day. Thank